Alright, so in this video, I'm going to answer some questions for your review so that you can be ready to take your test and do well on it. First of all, notice we're going to be using this diagram to answer the following questions, 1 through 5. First, on number 1, I want you to notice it says, what is another name for line segment BJ? So I'm going to go ahead and just highlight real quick. When we talk about line BJ, that's this line segment right here. And what I'm going to do when I talk about naming it a different way, we can simply just reverse the letters. So line segment BJ can also be called line segment JB. So that's for number 1. So another name for BJ is just JB. On the other hand, number 2, it says, what is another name for Ray BJ? Now I know this is a ray because if you look, it doesn't have an arrow on both ends. It just has an arrow on one end. So it has an endpoint and an arrow on the other end that goes on infinitely. So this is a ray. And instead of writing a ray as BJ, in other words, I'm going to get my highlighter again, they're going from the endpoint of B all the way through the end where it goes forever, through J. So instead of, since they've already written it as BJ, we can't reverse the letters. That would be wrong. So what I'm going to do instead is I'm just going to write it out as Ray BJ. So in other words, we just write it out as a word. Next, it says name all rays with the endpoint O. Okay, I'm going to use my red pen just to mark the endpoint O. This is the endpoint O. So I want to think about all rays that I can create if this were an endpoint. Well, one would be OJ. So I'm going to just write the ray symbol and I'm going to write OJ. Now they're all going to start with O because this is my endpoint and then it goes through the other point. So every one of these will start with O. So then I have OD, so ray OD. And then I have ray OB. So ray OB, and then I have ray OH. And those are all the rays that we can name with the endpoint O. On number 4, it says name one pair of opposite rays. So opposite rays just means that we have a ray coming from the same endpoint. Now we already used O as an endpoint earlier. So let's say O is an endpoint, right? And let's say we want to do opposite rays. So I'm going to do this with my red pen. So I could say that OJ, I'm just going to go ahead and write over it red. So if I were to say OJ, that's one ray. And its opposite, right, because it wants a pair of opposite rays, would be the one on the other side going the other direction. So instead of OJ, the opposite ray would be OB. OB. And those are opposite rays, right? One is going this way, one is going that way. They oppose each other. Next, it says the figure below is a rectangular shaping box. Name 2 different planes that contain DH. So notice it looks like a line symbol and it says DH. So I'm going to go ahead and I'm going to highlight DH so that we can see where it is. So I'm just going to go ahead on this particular problem and I'm going to highlight some things. So I'm going to go ahead and highlight this plane right here. So notice you can see this one that's on the side and I'm going to call this one DHG. So that's plane DHG. And then we need one where it says name 2 different planes that contain DH. So we need another plane that contains DH. So DHG contains it. And then I'm going to highlight the second one in orange. And this plane right here. And if I wanted to name the second plane that's orange that contains DH, then that one is going to be plane, and I'm going to use 3 letters from it. So A, E, H. So A, E, H. That was the orange one, so I'm going to box it in orange. And the second plane that contains DH is going to be the yellow one. Notice in this problem, it says it wants me to find AC. So I'm trying to find the length of AC. In other words, from here at A, all the way over to C. Now, if I want to find that entire distance, I got to consider what they have here. Notice they're showing me two different line segments. So they're telling me from A to B, we have a total distance of 12 units. And then from B to C, the rest of the way over, we have a total of 20 units. So if I want to find A to C, in other words, what I'm trying to find is from here, the total distance all the way to here, I need to add these two values together. In other words, I need to take 12 and add it to 20, and that'll give me 32. And that's how long this line is. So from A to C, it's 32 units. So line segment AC equals 32 units. On number 7, it says find AB. So we're trying to find this distance right here. And I recommend always drawing it out. We want to find this. I'm just going to call this X. We're looking for X, the distance between A and B. And I'm going to highlight it right quick as well. Now, notice we're given some other distances here. And so we're going to take what we know, and we're going to use that to help us out. Now, what we don't know is just A to B, but we know that B to C is 29 units long. And they've helped us out up here because they've told us that the total length all the way from A to C is 41 units long. In order to find this segment right here, when given a total value and a partial value, I want to take what I know, which is this total distance from A to C. I'm going to write beside it AC. It's 41 units long. And I know that if I subtract B to C, which is 29 units long, from it, what I'm going to be left with is this little short distance, which is A to B. So this is just one way you can go through it and think about it. So let's see. If I borrow from here, I'm going to be left with 2, and 2 from 3 is 1. So I know that AB is going to be equal to 12 units. Now you could have done this if you wanted to write an equation, right? You could have wrote an equation from this. You could have said X plus 29, which is this side over here, is equal to 41. And the process would have been the same. The only difference is here we're creating an equation so you can show how it's done algebraically. And I would have said, you know what, I'm going to subtract 29 from both sides of the equation. That side cancels. You're left with X is equal to 12. So, right, this is how you would do it if you wanted to set up an equation. But in a problem like this, because it's pretty basic, you can just set up a simple equation, right? Just like this right here. Just use some old school math. Now let's go to problem 8. All right, so on problem number 8, it says point M is the midpoint. Now that's a very important word because that means that it's half the distance between these 2 points. So in other words, there's my M. I'm just going to highlight it real quick. That is half the distance. Then it says find BM. Now initially this may look confusing because sometimes with these problems they'll give you a total distance, right? And then you have 2 expressions. But in this case they're telling us this is the midpoint. And because that's the midpoint, what I got over here on the left has to be equal to what we have on the right. In other words, A to M is going to be the same distance as M to B. Now if I go ahead and I take my equation, I'm going to write it out real quick. I have 4x plus 13, and that's going to be equal to 3x plus 17. Now we're going to do some math here because we want to go ahead. It's telling us that, you know, M is the midpoint, but it wants us to find BM. So it wants us to find an actual length between here and here. I'm going to call that right here. We won't call it x because we're going to substitute for x. But actually, you know what? Let's just put a question mark to prevent any confusion. So we don't want to know the distance between b and m. And the first thing I have to do is I've got to figure out what x is. We don't know what x is, but we can find out by setting these equations equal to each other and solving for it. And then we can substitute x back into this expression right here and figure out what's the total distance of bm. So I'm going to go ahead, we're going to do some math real quick. We're going to want to use inverse operations. So, right, if we're adding 13, so we subtract. I will do the same to the right side of the equation. And 17 minus 13 leaves me with 4. Now, I want to get all my variables to the left side of the equation, right? Because every time we solve an equation, we want variables on the left, and we want constant values. And if you forgot, constant is just a name for a value that doesn't have a variable. Constant values on the right. So this is a positive 3x, so I want to subtract 3x from both sides. And 4x minus 3x, this leaves me with simply an x. And so this one, we didn't even have to divide anything out because we had a positive coefficient of 1 in front of our x. So we have x is equal to 4. But now that I know x is equal to 4, I'm going to use this expression right here, which represents the bm, the distance or length of bm. So 3x plus 17. And what I'm going to do is I'm going to substitute this value that we found for x into my equation, or I should say my expression. And then I'm going to evaluate this expression. In other words, I'm going to go ahead and perform the operations that you can see here. Now, you could just throw this all in the calculator, right? Make it real simple. But I know that 3 times 4 is simply, if I distribute this, it's going to give me 12. And then I got plus 17. And if I add 12 and 17 together, that's going to give me a total value of 29. So in this case, I know that BM, I should say line segment BM, is going to be equal to 29. All right, in this particular problem, number 9, it says identify the segment bisector of AB. So line segment AB, then find BM. Well, a bisector means it cuts it in half, right? And just looking at this M right here looks to be the bisector. That's the halfway point, or what we would also call our midpoint. So M is going to be my bisector. Notice I do have 2 expressions on each side, and much similar to the problem that we just did, if I want to find BM, which is just the distance between here and here on that line segment, I will first have to solve for x. Once I find x, I will substitute it in place of the variable x in the expression that represents the length of BM, and then evaluate it, and I'll have my answer. So I'm going to first take this expression on the left, in other words, a to m. It's 4x plus 1. So 4x plus 1 is equal to, and then we have 7x minus 35. 7x minus 35. I should have put that 1 in red. I like keeping them separate. My constant values are going to be on the right, and on the left is going to be my variable. So this is a positive 1. We're adding 1. So I'm going to do the opposite, which is subtract, which cancels my constant value on the left. I'm going to subtract 1 over here. And if I were to put this in a calculator, negative 35 plus negative 1, it would give me a total of negative 36. But I recommend when you're doing these, use your calculator to add and subtract integers. Now I need to move this 7x over to the left side of the equation. That's a positive 7x, so I'm going to use the inverse operation, which is to subtract 7x. And I'm going to do that on both sides. That leaves me with 0 variables on the right, and 4 x's minus 7 x's, or I could look at it as 4 minus 7, just subtract out your coefficients, is going to leave me with negative 3x. Now I'm in my final step. All I have to do now is get rid of this coefficient of negative 3 that's in front of my x. And the way we get rid of a coefficient is we just divide. Because negative 3x means negative 3 times x. So the opposite of multiplying is dividing. And whenever you draw a fraction bar or turn something into a fraction, it's just division. So we divide by the coefficient. But I need to remember to also divide by the coefficient on the right side. So 3 going to 3 one time, that leaves me with just x is equal to, and negative 3 will go into negative 36, positive 12 times. And once again, if you're not good at doing math in your head, and many times as I'm doing these problems, I'm always checking my answer with a calculator. Just throw that in the calculator, because you might have forgot the rule. Maybe you'll get the number right, but you might have forgot the rule that says a negative divided by a negative becomes a positive. So now I know that my x value is 12. Now that's not the answer, but it's the first part of getting the answer. So since I know that x is 12, and now I'm going to take this expression right here, representing bm, so from b to m, and I'm going to substitute 12 in place of this x. So I'm going to draw a line just so we can separate it. And what I have here is I have 7x, the letter that we're going to substitute, minus 35. Now I'm going to go ahead and I am going to substitute this value of x with a 12. I'm going to bring down a 7 minus 35. And you know what? And we're dealing with some bigger numbers here. I'm not going to take a chance at making a mistake. So I'm going to get my calculator and I'm going to do 7 parenthesis 12 close parenthesis minus 35. Hit enter and it tells me it's 49. So I know that when I evaluate this, it becomes 49. So therefore BM, line segment BM, is equal to 49. Now you ready for the next problem? Alright, in number 10, notice it says the endpoints of GH are G, negative 3, 0, and H, 7, negative 8. Find the coordinates of the endpoint. So you're given the endpoints. That's an endpoint, and that's an endpoint. And then it wants you to find the midpoint. For this one, I've already made a video on this topic, so I'm not going to do it in this video. What I want you to do is go to the DAEP website and look up the tutorial for midpoint. So you're going to see one that says midpoint tutorial. Watch it and it's going to show you exactly how to solve that problem. On number 11, it says the midpoint of GH is m equals negative 6 and negative 3. One endpoint is H, which is negative 4, comma 4. It says find the coordinates of the endpoint. So this time you're not given two endpoints. You're given one endpoint and you're given one midpoint. So I'm going to box them. That is my midpoint. And this over here is my endpoint. So go to the DAEP website that I created for you. And I want you to watch the video that says, it's titled, Finding Endpoint when given an endpoint and midpoint. So go watch this video and it is going to take you through the steps on how to solve this problem. In this next problem, it says in the diagram, it says the measure of BDA is equal to 144 degrees. And then it tells you to find the measure of ADC. So angle ADC. So let's take a look at these angles real quick. So first of all, I'm going to highlight the angles just like I highlight them up here. So it says BDA. So if I go over here, this is B, D, and A. So this whole angle from one side to the other, and I'm just going to draw kind of an arrow here. Little arrows, we usually draw it, right? So in other words, from this side all the way over, or you could look at it from this side all the way over, we are 144 degrees. That is the angle. Now, it wants you to find the measure of ADC. So I'm going to highlight that. So of A, D, and C. So notice that angle's been cut, right? It has this right here, dividing the angle into two angles. And so we're going to use what we know to be able to solve it. So a couple things are important for what we have. They've given us some decent information here, but the most important that I see right here is it looks like notice this has a little angle symbol right here. It looks like it's saying this angle right here is 7x plus 34, and this angle right here, so I'm just going to draw a little line, is 9x plus 46 degrees. So knowing that, we know that the whole angle is 144 degrees, and that if you add this angle up plus this angle, it'll make a whole angle. Now I know the arrows, at least to me, it looked a little confusing in this problem because it looks like it's pointing at a line, but it really means this angle inside of here. In other words, if I were to highlight it, right, in other words, this represents this angle right here is how I'm seeing it. And this one that's highlighted in yellow right here is representing this angle on the other side. Now, knowing all of that, I know that this angle, in other words, plus this angle equals 144. So I'm going to write that out. So I got 7x plus 34 degrees. Now, I'm not going to put the degree symbol on my number. I'm going to leave it off because for me, it just kind of mixes me up. I'm just going to write the number 34. And I'm going to put, if I take that and I add it to this other one, 9x plus 46 degrees, then all of that added together should be equal to 144 degrees. So now we have a basic equation that we can solve. The first thing we want to do if we're solving this equation is we want to combine like terms. So there's a couple things right off the bat that I see are alike. I have a 7x and I have a positive 9x. I'm going to put those together, and if I add 7 plus 9, that gives me 16. So that's 16x. Then I'm going to add my constant values. I have this positive 34 and a positive 46, so let's put those together. And if I add 34 to 46, that's going to give me 80. So we have a positive 80 degrees when we add those two together, right? 4 plus 6 will turn this into a 50, plus 30 more will be 80. Now, I'm going to bring down my constant value. I'm going to change the color. So I'm going to start keeping all my constant values red and my variables black. And what I want to do next is I want to move this constant value to the right. Just like we were doing with the other equation, we always want the constant on the right. So I'm going to subtract 80 from both sides, minus 80. Now, we don't want to mess this up, right? So we want to use a calculator if you have one. And so I'm going to take 144 and subtract 80. And it tells me that this is 64 degrees. Now, the only thing I got left on the left side of this equation is the 16x. So I'm going to write 16x. My final step, notice I brought it down, wrote 16x and then 64. So my final step would be just to divide out this coefficient into both sides of the equation. So I'll divide by 16 on the left and divide by 16 on the right. And I'm simply left with x is equal to, and we'll just see how many times 64 can be divided by 16. And it gives me 4. So notice we have what x is, but what it really wanted to know was, it said find the measure of ADC, of A, D, and C. So I'm going to take this x value now, and I'm going to substitute it. So I'm going to write substitute into the expression that represents angle ADC, which is 9x plus 46. 9x plus 46. Now remember, we're going to actually substitute in for the x. We solved for x. We said that x is equal to 4. So in parentheses, I'm going to put the 4. I'm going to write my 9 out here. And I'm going to add 46 to it. Because this 46, right, I just wrote it down temporarily. But we're substituting for x, the value that we found x was equal to. So I got 9 parenthesis 4 close parenthesis plus 46. And it gives me 82. So if you look right there, we get 82 when we put that in. So this is going to be all put together 82. So what that tells me is angle ADC is simply 82 degrees. So what I'm going to do now is I'm going to take this where it says measure of angle ADC. I'm just going to write it right in front of it. The measure of angle ADC is equal to 82 degrees. And that's my answer for that problem. So it was a lot of work, That's how you solve it. On this next problem, it's the same way, right? It wants you to find the measure of angle BDC. So they want you to find BDC, and they're telling you right here that this angle is negative 3x plus 20. And then they're telling you down here that this angle, so right here, is negative 2x plus 55. And you might say, well, Mr. H, it don't look the same to me because they didn't tell us how much the whole angle is. Well, you do know how much the whole angle is. And when I say the whole angle, if I started here and I went through this whole angle right here, I'm going to tell you, in case you didn't notice it, that angle happens to be 90 degrees. The whole thing. How do I know it? Because they have a right angle symbol here. And that right angle symbol just tells you that this is a 90-degree angle. So when I set up this equation, I'm going to get you started on setting it up, and then you can finish it. I'm simply going to write negative 3x. And then we have plus 20 is equal, well, not equal, I'm sorry, plus. And then we have negative 2x. Now I am going to put this negative 2x right here. I am going to put it in a parenthesis because it has a negative sign in front of it. So negative 2x. And then we have plus 55. And this whole thing is going to be equal to 90 degrees. So equal to 90. And then you can solve it from there using the same steps that you see me use over here.